Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Find polygon with the largest perimeter. So essentially, the gist of the problem is you get an array, and the elements of the array represent sides of some shape, okay? And we want to return the largest possible perimeter of a polygon where the sides of the polygon can be formed using this array. And if we can't create a polygon out of some number of elements in the array, we return -1. And here they help us with the definition of polygon, and they say, so first it has to be at least 3 sides, so at least it needs to be formed by at least 3 numbers. It can be more. But the other condition is that the longest side, so the largest number, is smaller than the sum of all the other sides. So basically, the maximum, when you choose a set of elements in the array, the maximum needs to be smaller than a set of than the other side. Okay. So let's see how we can tackle this. The conditions we have are pretty simple. Just that we have longest sides, so that's why they represent here. Let's say we pick some set of elements, some set of k elements. Then the sum needs to be bigger than the largest side. So how do we sort of simplify this for ourselves? Well, this one here, the largest side has to be, if we sort the array, has to be the latest position among all the ones we chose, right? And so what can help is sorting the array. So we sort the array. Then after that, what should we do? Well, after that, once we sort the array, we can just check and find an index where we have this basically formula, right? Since all the other, we already know that AK being AK largest side, this one is already satisfied by the array. Okay, we can just find the indices that will give us this condition here, and so that's what we will do. So we'll just go through. Now, the largest value is at the end because we sorted, so we can just start from the end of the array and go down by 1. But when should we stop? Well, the problem says that polygon has at least 3 sides. At least. So that means we need 0, 1, index 2. We should stop at index 2. Okay? Okay, and so to stop at index 2 in Python, you need to go 1 step down so that it stops at the +1. So when we do up to 1, this means it will stop at 2. And now what should we do? Well, we want the largest one, which we know in this case it's I, because that's literally how we are doing it. Basically, what we are doing here is that with the elements of the array we have, so let's say these are the elements of the array, something like that. Okay. Let's say this is our I position, that each time we check I here, we check if this forms a polygon. And so what would be the sum of, what would be the highest one? It would be at position I. What would be the sum of the other ones? So this one here, well, it's all of this. So how do we represent all of this? Well, this is just the sum. This is just the sum of everything up to I-1. So up to this position, which is I-1. And so we just need to get the sum of all of these. And so what do we need to check? We need to check that this one is actually smaller, so like this. Okay, so we check first for the sum. And then now what should we do? Well, we are looking for the best perimeter first. So that's what we are looking for. And the problem says if we are not able to find a valid polygon, we need to return -1. So let's initialize it to -1. And now here we want to look for, see if the current one, that is from I to the end, we want to see if this one, I have some more here. So we want to see if this one here is the best perimeter we can get. And so we can just take the sum. Now this one is, the sum is up to I, because this is the largest side, but it's still part of the polygon. And so we need to just do I+1. Sorry, I+1 to end at I. And then at the end, we want to return just the best perimeter we have. Now, of course, this would be slow because it's O(n) squared, because we do O(n) here, O(n) here, and then we do another O(n) here. But just to illustrate, So we need a proper index. Let me just first remove this one, the largest one. So yeah, this needs to be -1 because that's the so we actually need to set the best parameter here. And so from this looks good, but this is very slow. So how do we optimize it? It will not pass with time limit exceeded. So what is the easiest way to make this efficient, getting the prefix sum? Well, it's to actually use a prefix sum. So we can calculate a prefix sum here. Now in Python, it's really easy. If you prefer, you can use a loop, but I'll just do the simplest solution, which is just using iterator's accumulate like this. So this will accumulate basically the prefix for the array, which basically means, for example, using this array here, it would be 5, and then we add the previous prefix sum with the current value, so 10, and then we add the previous, which is 10, to the current value, which is 15. So you get the idea. This is basically the prefix sum. So that's what we do here. Now it's easy to find the sum up to I. It would be just the prefix sum of I, because that's literally what we did to construct the prefix sum. And so this would be, this sum here is up to the index before I, so up to I minus 1. So this means we need to go to I minus 1, and this is up to I, so it's the prefix sum at I. Let me just name this properly. So prefix, and this is prefix. Okay, and this should work, and it should be O of n time, because we are only doing this loop, and this loop O of n plus O of n, so it's O of n. So from this, looks good. If we submit, it does pass. Okay. Now a different approach I want to show here is using a heap queue, so a max heap, where basically we extract the max element and check if it's smaller than the remaining element. So each time we extract the max element, we check if it's construct a polygon with the remaining element. Similar to this sorting approach, except it would be O of n instead of this O of n ligand here. So how do we do it? Well, first what we can do is we need to create our heap queue. Now our heap queue will need to be max. So in Python you could do that with just making the array element negative, and then we heapify it. So heap queue dot heapify heap. Now we will get rid of this prefix and do something different. So what we can do is current sum. We'll start with the sum of all the elements of the array. And what we'll do is we will check. So of course, while we have elements, what we need is basically the sum of the remaining, which basically is going to be represented by this current sum. Let's call it actually a remaining sum. So this sum here, we will need it to be this is the sum of everything plus the highest element. So if we subtract the highest element, which with the heap queue is just, with the max heap queue it's -0. Of course we do minus to cancel this minus here. Well, this needs to be bigger. The Polygon condition says it needs to be bigger than the highest element, which is this one. Okay, so let's call that like this. So if we add this just to cancel it out, then we would have plus. So what this tells you is we have 2 of this, and so we can just multiply by 2. Okay, so this is the condition for it to be a polygon. But the other thing to notice is that since we are extracting the largest element and summing up the rest, once we find the first one that we find like this, we should stop, because that would be the largest element. Because if we continue, then first we will get a smaller largest side, but also the remaining sum would be less, and so the overall parameter would be less. So it makes sense to stop at the first one we find. And so our while loop condition can actually be the reverse of this, which is smaller or equal, because as long as this is the case, that means we haven't found any parameter yet. But as soon as we find the first one, we know it's the max and we should stop. So that's exactly what we are going to do here. Okay, now what should we do here? Well, we find that this max doesn't create for us a polygon, so we need to remove it. And so how do we do it? Well, we need to remove it and subtract it from the remaining, because we are no longer considering it, right? And so we subtract it from the remaining. So we need to extract it out. So this will remove the max element. But also, since we started with minus, we need to put minus here so that it gets us the original value. Now here, that means when we exit this while loop, that means we have the first condition that creates a valid polygon. And so basically what's the perimeter? Well, it's everything that we have remaining, because that includes the largest side and includes the other sides. Now, but this is the case only if we have 3 sides. If we have less than 3 sides, then there is no polygon. And so we need to check that the length of the remaining elements is actually bigger than 2. If it's not, then we return -1. Okay, so we actually don't need this value here. And this gets accepted. Now, this is faster because as soon as we find a solution, we return. We don't go through everything. Now, again, with these problems, I want to show you more APIs in Python APIs so that you can learn to use them more in the future, both in your Leetcode algorithm, but also like just in Python projects. So one thing that is basically confusing here is this minus, because we need the maximum, a maximum heap, but the problem is Python has this minimum heap. And so we are doing that by putting minus so that we get the max. Another way to do it is to actually use this thing in Python called heapify max. So this will create a max heap for you. And that way you actually don't need a one with negative, so we can just use A. And we don't need to add the negative here. But we also no longer need to add the negative here. But to get the max in this specific case, we need to use pop max to give us the maximum one. And so this now is A. And this is easier to read because it actually says what we are looking for, a heap max. So if we run this, looks good, submit, and it does pass, okay? Yeah, so that's pretty much it for this problem. I hope this was helpful. Thanks for watching and see you on the next one. Bye.